everyone. Welcome to the National Cryptologic Foundation Cyber Chats. Today, we have as our speaker Frederick Hall, who is an Army veteran who actually began serving in the Army soon after high school as an information systems operator. He worked in many different levels in information technology, help desk technician, system administrator, domain administrator, firewall engineer, exchange administrator, and domain enterprise administrator. He has been stationed all around the world. In his civilian career, he has been a network defense operator, worked in cyber operations, was an enterprise administrator, and is currently working as a network engineer. In his off time or spare time, he is a merit badge counselor for the Boy Scouts of America for digital technology and cyber safety. He also volunteers as a cyber patriot coach for Medina Valley High School and through the Hodo Public Library in Hodo, Texas. He mentors for an all-girls team at Davis Middle School in cooperation with Brown STEM Incorporated. And he also teaches a Cyber Patriot Cyber Generations safety course for senior citizens. Fred has served in numerous Cyber Patriot and cyber education camps, and is also a character since September of 2019. He's also a contributor and a character in a chapter book called Journey Through the Unified Field, which is a chapter book for middle school students that encourages young ladies to pursue a career in STEM or STEAM career fields, specifically in cybersecurity. So welcome, Fred, and I turn it over to you.
Thank you, and everyone at the National Cryptologic Foundation and Empress for inviting me back to conduct another session in the area of cybersecurity. Today's topic, of course, as you've seen, is for firewalls. And I'm going to share my screen out real quick. Today's world is interconnected. Everything talks to each other. Everything communicates with each other, whether it is on the internet or whether it's in a private home network. Everything is now connected. It's talking with each other. Bluetooth, Wi-Fi, a different array of different signals that are being scanned across and thrown across the air, which you can't see. And the number one thing that all these have in common is they all need a network. And the number one thing you need to protect, or that first layer of defense in protecting your network against certain things, are firewalls. There we go. How'd you like that animation? Firewalls are the first layer in a multi-layered defense for your network. And when I say multi-layered, it's not just a firewall. You might have two firewalls. You have antivirus. You have anti-malware software. You also have hardware that scan for certain anomalies on a network or in your system and detect things that don't need to be there or aren't supposed to be there and alert you before something bad really happens. And the first thing that always protects a network are your firewalls. So today we're going to go over a basic overview of what a firewall does, the active role it plays in network security, how they're used, how a firewall works, and where they are actually when you install them on your network. So what is a firewall? A firewall is a hardware appliance where you can rack mount or set next to your modem or connect to your router that actually helps detect incoming and outgoing traffic. It's an actual piece of hardware, or it could be a piece of software that you install or it's natively installed on your operating system. They can work in tangent. They could be individually working independently. But the job is the same. It's to help block certain ports of communication or certain communications or allowing certain communications to come into your network onto your computer. Here we have an illustration of a firewall, and this is an appliance firewall, an example of a specific firewall. This is the kind that you would find in an enterprise or in a rack, someplace where you work. And right here is something very older model, but it still does the same thing. It protects your network, which is over here, from the internet, which is what you're trying to do to stop bad guys, hackers, malicious code from entering. And as you can see, we have an external side, which is what we call the dirty side. And you have the clean side, which connects to your network. And I'm going to try to zoom in a bit so you can kind of see what you would connect to, or what your switches or routers would connect to. Each one of these is an actual connection, and in this case would be what we call RJ45 or a Cat5 connection that goes from the device. So these are going to the outside portion, which connect to the internet, because you'll have many routers that go into the outside, many other pieces of equipment they have to connect to before it enters your network. And this side would be from where your internet work, where all your devices, servers, switches, computers would connect to. This is where all your traffic comes in and out. This is where it gets scanned. And as you can see over here, you would have your DMZ, which is another form of helping protect your network. Then you have your two networks, well, three networks, because you have your wide area network there. On this side, of course, we have the internet, where all the bad guys and all the everything else lives. So this one piece of equipment specifically does a lot of work to help protect your network. Now, if you were to go inside of an actual firewall to see what it looks like, whether you're going into the appliance like we previously had, or if you have a software that you loaded and you're using as your onboard software firewall device, here is an example of what you would see when you go to configure your firewall to allow your certain ports of traffic or certain communication ports in. So right here is where you would input your global addresses, what is trusted, what you want to block. So you know anything that would trust it would be inside your internal network. So if you're trying to talk to another computer via a switch, you want that IP address in there. Trying to talk to a printer over your network, you want to be able to do that. For instance, your webcams and what we're doing today, you would want these IP addresses allowed to communicate through the firewall. Anything that's blocking is something simply, it's not necessarily hackers or viruses or anything you think is bad. Maybe something causes too much traffic. You don't want that going out. You just want it to stay internal. You would block it right here. Where's my arrow? Over here, we have a service that's being used. So you can block or allow traffic just on services. So you have what we use for email is called Simple Mail Transfer Protocol, or SMTP. And it uses that. But right here, we have what's called FTP data. So FTP is File Transfer Protocol. And you want to be able to transfer files through your firewall to get from one point on your network, either out to the internet to another site, or through another network, say at another branch if you're working at a bank, to transfer files. So you would want this either blocked or open. Next, we have the port that's being used. Each protocol that's used for communication, whether it's FTP, secure FTP, SSH like we have on here, SMTP, are associated with a communication port. There are 16,000 communication ports available for everyone to use. And there are basic ones that are always going to be standard, like port 80 is always what's used for the internet, or HTTP. But you have to know which port you're using and which protocol you're using in order to allow it through the firewall. And over here we have whether or not you're going to use TCP or UDP protocols, because you have TCP ports or UDP ports. Now, there's a difference between the two, TCP and UDP. And that would be TCP is more secure. You have to authenticate with TCP. It takes a little bit longer, but you know it's a secure connection. You know it's going to connect because it keeps trying until it gets an authentication with whoever it is you're trying to connect to. UDP doesn't care. UDP is just going to send it through. It's going to connect. If it connects, it's good. If not, it drops it. So it's faster, not as secure, but it gets the signal out there. You're able to establish communications a bit quicker. Now, once the traffic enters the firewall, it goes through a series of checks. It's going to look for your IP address to see if there's anything, or if there's our IP address is blocked. It's going to look for the protocol or the URL that it's using. Inside of your firewall, you're going to have lists of blocked addresses, blocked IP addresses, blocked protocols. All these things are going to be checked as the traffic is going out. So you have your source routing. Where's the signal coming from? Where are you at? That is your source. Your IP blocking. Okay, we don't want this IP address going out. We're going to block this, and the signal's not going to go out. You're not going to be able to communicate. Application backdoors. So sometimes there's some applications, if you have one, get a virus installed on your computer, and it opens up what we call a backdoor to a port to allow communication out to the internet to the bad guy that's infiltrated your machine. The firewall can monitor all this, and if it sees something, it'll block it automatically because it'll mark it as suspicious traffic. URL filtering. There are filters for websites, and you can either build them or some of them already come pre-configured and categorized. So say some websites, you don't want people shopping while you're at work. There is a whole filter full of thousands of URLs for shopping websites. And you can either block all of them, block some of them, or allow all of them. The firewall will allow you to do this. Check for viruses. Now, as you're communicating and you're going out to the internet, sometimes you start to download stuff, or sometimes in the midst of you communicating, going to a website, you might get redirected automatically and not even know it. Something happening behind the scenes. The firewall can detect that if you have it configured correctly or configured to do this. So if it sees something coming in and it doesn't like it, it can stop the traffic or just tell the computer that you're trying to download from, hey, nobody's here, and the traffic will stop. Network address translation. When you're at home, everybody has a modem and a wireless router, assumably, right? Or some kind of router where all their devices are connected to. Well, when you have an IP address, and that's what's used for you to communicate out to the internet while you're at your house. Network address translation allows you to take that one IP and to break it up into many IPs. So you can have up to 25, 30 devices on your home router, which use the same IP to get out. That's what a network translation does. It takes one IP and converts it to another to be used over multiple devices. So you don't need to pay for multiple commercial IP addresses from your ISP. So when your request is made from a user to go through the process, getting out to the through the firewall to the internet, but I got to read the rest of this. It goes through the user sends out the request. It goes through the firewall. The firewall goes through the check. He says either yes or no, you're allowed to do this. And if the traffic's allowed, it comes right back in. If it's not allowed, the firewall will block it and you won't be able to get to the website. Now, this is good depending on the filters you have set up, or if the firewall has detected something that's malicious and I want you to stop using or trying to connect to that website. So in the next couple of slides, we're going to see what a small home network looks like with a firewall installed. And then we're going to see an example of a large enterprise network architecture and how firewalls are used in both networks to protect everything behind it. So here we have a home network. Simple basic setup like I was talking about a few moments ago. You have the internet right here. All the traffic comes in. You hit the firewall, and you notice how these two streams are stopped, and only this one is allowed through to connect to your modem, which connects to your home network. This is blocking a lot of information, which is what you want. You only want certain things to come in or nothing at all to come in, and you want all your traffic to come out. But you might have different things configured on here that you would at work. So it's a lot smaller, it's a lot easier to maintain, but it's still doing a lot of work at protecting your entire network from any malicious attacks. Now, here is an enterprise network architecture, much larger, what you would see at an organization or a business. And you would usually see a setup like this for anywhere because they want multiple points of communication. Because when you're in a business, you don't want to lose communication to the internet. So as you see, we have two routes coming into the core of their network, which is right here. And they have two routers which talk to each other, and they have two firewalls that talk to each other. Now, this is important because when having these four devices connected up to each other, it will create what's called high availability. So you always have a route of communication. So in this example, this would be the main route coming in. This is coming from your internet service provider A. This comes in, this is where the main route's coming in, everybody connects this way to get in and out. This would be your ISPB would be your backup route in case A goes wrong. So if A goes down, all the traffic automatically gets diverted to B. And the firewall still stays in place to protect the network. Very important to know this because even though this firewall's down and you're past this router, they're still working in tangent together. So this is still getting diverted. These can communicate to allow traffic and still allow the routers on the inside of the network to divert traffic and allow communication to continue.
Quick question.
Yeah.
Why is it on my home network, I want high availability as well. I want to make sure I have the internet all the time. Why can't I have, multiple firewalls and multiple ways to get to my ISP like you've shown here on the enterprise network?
Right. So I'm going to go back a slide. All right. So usually in a home network, you're only paying for one modem unless you work from home, which would be this thing right here. So if you pay for two modems, you can then get two firewalls and set up your two routers the exact same way and still have the high availability. But you need what's called redundancy in order to create the availability. So unless your single unit here has what we call a chassis or two chassis in one, the only way to get that redundancy is to have two of everything. That's why usually you only see it in the enterprise because these devices handle a lot of traffic and the equipment costs a lot more. But you can certainly do it at home. You just have to make sure you have the same type of equipment. Does that answer your question?
That was good. Thank you.
Moving on, we're going to talk about natting or network address translation, kind of what we touched on a little earlier in a few slides ago. So this is a generic page of what you would see in your firewall or your router that would allow that network address translation. So right here is your external IP address. This is your internal IP address, right? Because there's multiple tables. You can have, say this is a company, multiple external addresses for different networks. So if you're the headquarters and everybody's talking to you, you can manage the different networks and how they're being used from this point. So as you can see, we're going straight into here. This is the protocol we're using, which is TCP because it's more secure. And notice how they are using the same port number because it's the same type of communication that they're doing. It could all be SMTP. It could all be for web traffic. And what people don't realize is just because you have a designated communication port with industry standard, say for web, which is port 80, in your networking devices, you can change the port number depending on what you're trying to do. So say like, I don't want port 80 to be my web route to get out anymore. I want port 6881. You can configure your router and your firewall to allow that HTTP traffic over those port numbers, giving you an added layer of security on top of using the firewall and everything else that goes into network protection. Now we're going to talk about some specialized firewalls. Firewalls just don't protect networks or protect your computer. They can also be used to protect email. I used to use a email firewall at one of my positions, and did a lot of great work. It stopped a lot of spam. It stopped a lot of email-borne viruses from coming into the network. And what would happen is in the network architecture, it would be behind a regular firewall. It would be in front of your email server. So it would scan all the emails as they came in. So they would take the email, it would break down, it would look at the header information, and it would look at the attachments. And if the protocols were off, or if it saw something malicious in the email itself, it would quarantine the email, and the email wouldn't even make it to the recipient inside the organization. So it would stay there until a person had a chance to review it, and they either pass it on, or then they could delete the email. But firewalls just aren't specialized for email. They could be specialized for just about anything nowadays. If you want something for, say, webcasting like this, you could try to set up a firewall to block anybody else from coming in over your webcast like we're doing now. You can do it, for gaming. You could do it for any communication that you're going out over the internet. So in conclusion, couple things to remember about firewalls. They're either specialized appliances, which you can mount or use a piece of hardware, or they're software applications native to your operating system. Like the Windows has a built-in firewall, Macs have a built-in firewall. Linux, you could download a firewall and install it because it doesn't come native, but it's a piece of software that helps your computer protect itself from allowing and denying traffic from coming in and out. You protect your network integrity by opening and closing communication ports. So you always want your network to be available and safe. This is the first line and one of the most useful tools to making sure that your network, stays up, is free of anything that isn't malicious, it isn't supposed to be there, and it allows traffic that only you want allowed to enter, and all your traffic allowed to leave. It blocks viruses, spyware, and malware. Now, today, and this is still staggering, the number one cause of spyware, viruses, and malware are email. So if you don't have an email firewall that blocks all that stuff coming in, and you get a malicious email, and you click on the link, and you open a port, the firewall can block the port. So it can't communicate out. You can't open what we call backdoor for a bad actor to allow themselves into your system. So firewalls do a lot to protect not only the network, but your computer and information as well. They use URL lists, so harmful websites can come in. So there are a lot of websites out there that pretend to be websites that they're not. So you might actually hit Microsoft.org instead of Microsoft.com, and somebody else besides Microsoft owns that website, but they look just like it. But what they're actually doing is working behind the scene to infiltrate your computer or your network. If you're keeping your firewalls and URL lists up to date, they will not be able to access anything behind that firewall, which is a good thing. They can scan emails, they can scan attachments, they look for viruses and files. Very hardworking things, they're specialized, and they're just the number one thing to have on your system. With all these working together, your computer will be safe, your network will be safe, all your devices will be safe. And with that, that's my presentation on firewalls. Anybody have any questions?
A lot of students have received Chromebooks and other electronic devices, especially over the course of the last year because of COVID. So how can the students, even though they may be told that all of those things are in place, the firewalls are in place and so forth, how can they make sure that the device that they have is indeed protected? Is there a way that they can check when they're assigned that device?
When the student gets their device from the ISD or school district, they have things in place already. Okay. They should have the firewall, they should have the antivirus malware protection already in place. They should also be sending home instructions on how to update all of these things. Okay, now, or they're telling the kids or students to come by the school, because they'll have the Wi-Fi extended out past the school if they're locked out again, to connect to their network to allow all the updates to either automatically update or hit a button to update. Now, if a student wants to see if their firewall is in place, now Chrome is a little different, but we'll just assume that you're using a Microsoft operating system. A quick way to do it, there's always a search button. Always, whether it's Linux, whether it's Windows, whether it's Chrome OS. In this case, there's a little magnifying glass down here. Let me share my screen back out so you can see. Windows, we have a little search field down here. Like I said, the other operating systems have something similar to it where you can do a search. For Windows, all you would have to do is type in firewall. And here we have firewall. And it's going to open up in a second. Now, this is the internal first view you're going to see of a firewall. And you always want to make sure that it's turned on. See how it's turned on there? We don't have the public thing, so it's automatically off, so it's not going to be there. But if we go to the advanced settings, here is where we see how the firewall is actually working on Windows. All right, we have all of our rules laid out right here. We have a domain profile in case I take this somewhere and I actually connect to someone's network besides mine. A private profile, public profile. Inbound connections are blocked always because I don't want nobody coming into my computer. Right? Same thing on an enterprise network. You don't want nobody coming in or very few things coming in. Here's some authentication factors that are automatically in place. Monitoring, so it always monitors what's going on. Because when you turn it on initially, no matter what firewall it is, what firewall you're using, it's going to do what's called baselining. It's going to watch your internet network traffic behavior over like a 24 or 12-hour period. So it knows, okay, at this time of day, he's usually asleep, or this time of day, he's doing a lot of activity going on the network, a lot of watching YouTube, checking emails, stuff like that. So it knows how you interact with your network. So if it notices anything, say at 3 a.m. when you're supposed to be asleep and your computer's going out doing all this crazy stuff, something might be wrong. And it starts logging everything so you can go back and review it. Now, here are some default inbound rules for my computer. Now, some of this is just internal to the system. It's not really connecting out, but it has to go through the firewall to get to other places on the operating system. So, I mean, it's just private, right? It's mostly programming, backdoor stuff. Slack, it's okay, allowing if I'm going where it is. Outbound communications. Here's everything that's allowed outbound. There's a lot of stuff going out. Most of it's backdoor, well, not backdoor, but intercommunication software stuff. It has to connect with Microsoft.
Gotcha.
So, Skype, there's all the Microsoft stuff. There's some networking stuff that has to happen in order for the operating system to communicate, just in general. Now, if I was to go into one of these, because you can see the rules were always any, and you wanted to modify them, you can. And let me find one where I'm not going to mess up my machine that bad. So here we have one for iHeartRadio, right? Because I listen to the radio when I'm working every once in a while. I can allow the connection. I can allow if it's only secure. I could totally block it. Here I can set the port number. So if I don't want the port, whatever the program is using, I could set that port to a different port number to allow it to go out. Right? Any IP. Or if I wanted to go through a specific IP, I can narrow it down here. Advanced stuff. So where I wanted to go out all over if I'm on a domain, if I'm on private or public, I still want this to communicate. And that's what these are indicating right here. I don't have anything in here because I'm the only one on the computer. And I know when someone else is trying to access my computer. So I don't really need to worry about that. But you can always add others to remotely come in. So like you're a hotspot.
Mhm.
and you want someone to use your laptop or phone as a device to connect, you can allow them or put them on the list to do that right here.
But again,
Okay, so remote computers. Ma'am, go ahead.
no, I was going to say for the most part, for the students, all of this would have been all kind of programmed in, if you will, before they had received it, right? So
Yes,
okay.
all of this should have been pre-programmed in to certain things. It should have been pretty locked down
Mhm.
for them specifically because it's a school. They don't want them doing crazy things. At the same time, though, the school should have locked down the firewall so they shouldn't be able to see any of these settings.
Mhm.
Right. So hopefully they would have that locked down. I don't want any students going out there and say, hey, I can get around the password. Don't try it because they'll know. I know what my kids that I coach are very eager to do these type of things. And I gotta tell them, look, if it's not yours, don't do it. You're breaking the law because you're going past your agreement you have with the school. But they always try.
Right.
Or they at least ask me how to try. And I just tell them, no, it's not going to happen.
All right.
So how do we start learning to work with firewalls then?
Okay, so a couple ways. One is the number one thing, if you want to learn how to use a firewall, YouTube. What is a firewall? Kind of like this, where we posted out somewhere on the internet. What's a firewall? What's it do? What's the firewall I have? How does this specific firewall work? There's always a video out there on YouTube or somewhere equivalent to YouTube where it has an instructional video. Now, if you want to get deep down into the roots of how do I program a firewall and what are the protocols being used, there's a whole career field for this as you progress through your school career, going into your actual occupation. You can start off with networking. You can go into a network engineer. They have firewall engineers, or that's all they do is work on firewalls. They take the appliance, they put it onto the network, and you go through the courses. You go to the schools specifically for this. Take all the training certifications for it because there's different firewalls. They're not just one firewall fits all. You have many companies with their own versions of firewalls. So you can be specific to a couple brands of firewall and how they do it. But in the end, their job is all the same. Allow and block traffic. So the starting point is always curiosity, libraries, YouTube, ask a teacher. The one thing I will say is if you start playing with firewalls or you find a firewall at a yard sale, garage sale, or somebody buys one for you, don't hook it up to your network straight away, okay? Power it on, connect to it, get used to working around with it, and then try to integrate it into your network. Because if they try to put it up to their network at home, their parents don't know about it, and all of a sudden stuff's getting blocked, mom and dad are going to get pretty mad because they won't know what's going on.
Thanks so much for joining us. Bye-bye.
Thank you. Bye-bye.
Bye.